Hello and welcome. This is Columbia Basin Research's second video in a multi-part series on using Program ATLAS, which stands for Active Tag Life Adjusted Survival. ATLAS is a program created by Columbia Basin Research at the University of Washington School of Aquatic and Fishery Sciences with funding provided by the Bonneville Power Administration and the U.S. Army Corps of Engineers. Today, I'm going to show you how to load in and work with your capture history data. First, let's fire up the program. Type ATLAS into the Windows search bar. Then pick a study design type. I'm picking virtual paired release to start this tutorial. At initial startup, the only actions available on the navigation panel are load capture history data under capture history data and load tag life data under tag life data. Capture history data are required to do any analysis, and tag life data are required if tag life failure is to be taken into account. Optionally, after the tag life data file is loaded, attribute group file may be loaded that allows analysis of subsets of the capture history data. The capture history data file contains a detection history for each individual in each release of the study. Capture history files are CSV files that can be edited in Notepad, WordPad, or Excel and are generally created by the Tag Pro utility from processed acoustic detection data. This program is available on our website as well. You can create your own capture history as long as the file is in the following format. You can see here with the sample capture history file in Excel that column A is the release name, column B the bin number, applying multi-tag life curve, C the tag ID, D the activation date of the time of the tag, E the tag release date and time, F the detection site name, G if the tag was detected or not, 1 for detected, 0 for not detected, and H for detection date and time, blank if not detected. Date should be in the year, month, day, hour, minute, second format with 4-digit years and 2-digit dates. You'll note here that Microsoft Excel has formatted it in its own way, but you should be entering them in that format. The first line of the data file can be column labels if desired up here. If the first line labels are present, they will be ignored by the program ATLAS. In order to load the capture history data, double-click on Load Capture History Data on the navigation panel and select Capture History Data file to be loaded. Since I want to show you a fuller array of the capture history functions, I'm going to choose virtual paired release today. If you're currently in another design type, you can click Edit, Change Study Design, and Virtual Paired Release. Now we can see the various menus under capture history data that are now active and no longer grayed out. Double-click on Define Release Groups. Program ATLAS distinguishes between a release and a release group. A release is defined within the capture history data file and consists of tagged individuals grouped together under a release name, presumably all released from the same site at about the same time. A release group, on the other hand, is made up of one or more releases and defines a particular role specific to a given study design. The Define Release Groups action on the navigation panel allows the user to map releases to release groups. In other words, define what role each release plays within a selected study design. As you can see here, my R1 release group is checked as mapped to V1 release, my R2 release group to the R2 release, and R3 group to the R3 release. I could check or uncheck these as needed. Now double-click on View Mixing. With a virtual paired release study, as with a paired release study, it is important that the timing of releases be such that the fish from all release groups arrive at the downstream sites at about the same time. The View Mixing dialog allows the user to view how well that requirement has been met and also what release timing should be used for future studies. It is important to design the study so that the fish encounter the same conditions downstream and arrive at downstream detection sites at as close to the same times as possible. The View Mixing action on the navigation panel brings up the mixing dialog to see how well this goal was met. The graph shows the distribution of travel times for the release groups. I can display the results from each detection site, and I can enter the number of hours the R2 and R3 release groups were released after the R1 release group. By changing release times in the View Mixing dialog, I can also plan future studies to find out the best delay time in releasing the downstream release group. I now want to better demonstrate selection of downstream sites and the cumulative CJS and CJS covariance reports that are only visible in single release mode. So to do that, I'm going to need to reset my defaults via Edit, and I could do Clear Data or Factory Reset. Then I can change my study design to single release and then hit OK and then load in my single release data file. Then in this case, pick actual release, click next, and then select the actual release group, next. I'll cover more on the actual virtual releases and their differences in future videos. Double-click on Select Downstream Sites. This brings up the Active Sites dialog. Note that the first two sites are always listed as required. This is because a minimum of 2 downstream sites are required for a single release study. The number of required downstream sites is a function of the study design. By default, the checkboxes for the optional sites are selected, meaning they will be included in the analysis. If a user deselects a site, all downstream of the site will be deselected as well and will not be included in the analysis. Conversely, if a user selects an unselected site, all upstream sites are selected as well. Note that the Apply button must be pressed here for any changes to take effect. Below that is the Reports section, where you can see the Capture History Report, the CJS Report, Cumulative CJS Report, and the CJS Covariance Report. Double-clicking on Capture History Report and maximizing it, you can load the report. A capture history is a symbolic representation of the detection history of an individual fish. 1 indicates detection at a site, 0 indicates no detection, and 2 indicates detection and removal. For example, pit tag records may indicate removal from the river at or above the site. The capture history reads left to right, with the first field representing the most upstream site and the final field representing the most downstream site. In this example, 242 fish have a capture history of 1100, meaning that they were detected at the first and second sites and not the third and fourth. If I double-click on the CJS report, you can see the Cormack-Jolly-Sieber report for a study with 1 release. There is 1 line per release in both the survival estimates table and the capture estimates table. Here you can see the estimated survival from release site to site 1 along with standard error here, site 1 to site 2, and so on. The survival estimates in the CJS report are only perceived survival estimates. They are not corrected for tag life failure and thus are the combined probability of fish survival and tag survival. Double-clicking on the cumulative CJS report, which is only available in single release mode, gives the cumulative survival estimates to each site. The survival from release to the first site should be the same as the CJS report. The survival from the release to the second site is the product of the survival probabilities. For example, the release site 1 estimate of 0.96699 times site 1 to site 2 of 0.9624, which equals 0.9334. If I double-click on the CJS covariance report, I get the covariance matrix for CJS survival estimates, which is available in single release mode only. It allows the user to calculate the variance of a function of the survival estimates. The values are reported in full precision, and the user can readily copy and paste the table into a spreadsheet. In regard to this capture history data section, we'll cover attribute grouping and work with attributes in a future lesson. This has been lesson 2 on using Program Atlas, in which we detailed the ins and outs of working with your capture histories inside Program Atlas. Future videos in this series will cover how to load and work with your tag life data, as well as walking you through the single releases, paired and virtual paired releases, and attributes, and offering some hints and tips on maximizing your Program Atlas experience. Please note that if for any reason you are having trouble with Program Atlas and these videos are not sufficient to answering your questions, you can find the user manual at http://cbr.washington.edu/analysis/apps/atlas. The PDF manual is there, and you can either load that into the web browser as I'm doing right now, or you can download it and view it in Adobe. If you're using Program Atlas and you have any questions or comments, on that same page you may also give us feedback via our user satisfaction survey. We would greatly appreciate any feedback you have in helping us make future versions of this program to be more useful to our users. We hope that this video helps you get the most out of Program Atlas. Again, if you have any questions or comments in regard to Program Atlas, please fill out our survey as previously detailed. You can also contact Columbia Basin Research at web@cbr.washington.edu. Best of luck on your analyses, and thank you.